Hey everyone, and welcome back to Complicated Stuff on the Girl Has It All channel.
Hey everyone!
This is our 17th episode. Wow, I can't believe it's been that many already. And today we're diving into a topic that just never gets old for me.
Quantum phenomena.
That's right. I'm Thomas, a passionate advocate for all things self-discovery.
And I'm Jenna, the resident quantum expert.
We're both part of the Girl Has It All team, dedicated to, well, empowering all of us to be the best versions of ourselves.
Absolutely.
And sometimes that means getting our minds blown by the incredible things happening in the world of science.
Definitely. And these quantum discoveries definitely fit the bill.
Okay, I have to admit, I geek out about this stuff.
Yeah.
It feels like we're standing on the precipice of some major technological revolution, all fueled by these breakthroughs.
Sure.
But let's get into specifics.
Okay.
Researchers at MIT are making waves with something called edge states.
Right.
Now, Jenna, for those of us who maybe haven't been brushing up on our quantum physics lately, can you break down what edge states actually are?
So imagine a stream of electrons flowing along the very edge of a material, like a perfectly synchronized line of dancers, gracefully maneuvering around any obstacles.
I love that analogy.
Thanks! That's the magic of edge states. The electrons move without any resistance whatsoever.
Wait, so no friction.
Exactly.
If I'm getting this right, that means these electrons are moving without losing any energy.
That's exactly it. Think about it. Friction is the enemy of efficiency. It's what causes things to heat up and waste energy. But with edge states, the electrons flow freely, meaning you could transmit energy or data with almost zero loss.
It's pretty remarkable.
Right. Imagine the possibility.
We're talking about the potential for electronics that are exponentially more powerful and energy efficient than anything we have today.
Absolutely.
I'm already picturing a phone that never overheats. That would be a dream come true.
Oh my gosh, yes.
But how did the researchers at MIT actually create these edge states? It sounds incredibly complex.
It's ingenious, really. They used ultracold sodium atoms, cooled them down to almost absolute zero.
Wow.
Which is as close as you can get to completely stopping atomic motion.
So almost to a standstill?
Pretty much. Then they used lasers to create a sort of trap for these atoms and spun them around, cleverly mimicking a magnetic field using something called the Coriolis effect.
It's like building a tiny amusement park ride for atoms.
Exactly, it is.
So what? Okay, so they essentially tricked these atoms into behaving like they were in a magnetic field by spinning them really fast. That's a next level scientific ingenuity. And then what? How do they observe the actual edge states?
Well, they introduced an edge to this system using a ring of laser light, and guess what?
What?
The atoms started flowing along this edge in a single direction, just like electrons in a theoretical edge state. They even put obstacles in the atom's path, and the atoms simply flowed around them without any resistance.
So this is like proof of concept, right?
Yeah.
If we could figure out how to replicate this with electrons in actual materials, it could completely revolutionize the way our electronics work.
Absolutely faster, more efficient computers, batteries that last for ages, lightning-fast data transfer speeds.
Wow.
It's all on the table. This MIT experiment is a huge step towards making that future a reality.
It's pretty mind-boggling to think about the potential here.
Yeah.
But speaking of pushing the boundaries of what we thought possible, this episode is about more than just edge states. There's another team of researchers doing some really groundbreaking work with, get this, atoms acting as transistors.
Right, researchers at Purdue University are the masterminds behind this one.
Okay.
They've devised a way to use trapped atoms to control the flow of light.
Wait, hold on. Atoms as transistors.
Yeah.
I need you to break this down for me. How can an atom possibly act like a transistor?
Think of a photonic circuit as a highway for light.
Okay.
The researchers took cesium atoms, and just like in the MIT experiment, chilled them down to nearly absolute zero. Then they trapped these ultra-cold atoms on this photonic circuit right in the path of the light.
Okay, so the light is zipping along this highway, and it encounters these trapped atoms. What happens next? Do the atoms scatter the light?
Not quite. It's much more controlled than that. These trapped atoms essentially act as tiny gatekeepers for the light, depending on their quantum state, which we can manipulate. They can either let the photons, the light particles, pass through or block them entirely.
Hold on, are you telling me that a single atom can act as a switch for light?
Yeah.
That's incredible.
It is. It's the magic of the quantum world. It's like a light switch on an atomic scale.
I love it.
And by manipulating these atoms, we can control the transmission of light through the circuit, just like a transistor controls the flow of electricity in a computer.
So instead of electrical circuits, we could have optical circuits where data is processed using light.
Right.
Does that mean we're talking about the possibility of optical computers?
You're getting it. It opens up a whole new realm of possibilities. Optical computing could lead to incredibly fast processing speeds and a massive leap in computing power.
It really is like something out of a science fiction novel.
Oh, it is.
I'm trying to wrap my head around the implications of all this faster computers, more efficient energy. It's like we're on the verge of a technological explosion.
I think so.
But there's more, isn't there?
There's always more.
Tell me this isn't even the wildest thing happening in the quantum world right now.
You know, there's always more. And this next one is about our quest to understand one of the biggest mysteries in physics, gravity.
Of course, gravity, the force that quite literally keeps us grounded. What's the latest on that front?
Well, for years, scientists have been searching for a hypothetical particle called a graviton, the particle that's thought to carry the force of gravity.
And they haven't found it yet.
Not directly, but a team of researchers has made an incredible discovery. They've observed something that behaves just like a graviton, should they call them chiral graviton modes, or CGMs for short.
Okay, so CGMs are like stand-ins for gravitons, giving us clues about how they might work.
Yeah!
Tell me more about this discovery. Where did they find these CGMs?
They were observed in a very special type of material called a fractional quantum Hall effect liquid, or FQHE liquid for short. These liquids are like playgrounds for bizarre and fascinating quantum phenomena.
Okay, so by studying these CGMs and these exotic liquids, scientists are hoping to glean insights into how gravitons might work in the larger universe.
Exactly. It's a huge step towards bridging the gap between Einstein's theories of relativity, which describe gravity on a large scale, and the strange world of quantum mechanics, which governs the behavior of particles at the atomic level, and potentially unlocking the secrets of gravity itself.
Wow, I can't believe how much we've already covered, and it feels like we're just scratching the surface of what's happening in the quantum world.
It's wild.
These discoveries, they're not just incremental steps forward, they're completely changing how we understand the universe and the very nature of reality.
You said it. It's a truly revolutionary time for science, and it has the potential to revolutionize technology in ways we can barely imagine right now.
We've talked about faster computers and more efficient energy, but the potential applications are endless. We could be looking at solutions to some of the biggest challenges facing humanity, from new energy sources to breakthroughs in medicine.
Absolutely.
And while we're on the topic of revolutionizing our understanding, let's talk about something that blew my mind when I first learned about it. The fact that electrons actually have shapes.
Yeah.
Okay, I remember reading something about this. This is where things get really weird, right?
Definitely.
I thought electrons were just these tiny points, like little specks of electric charge.
Nope, not so simple. It turns out electrons have shapes, and those shapes have a big impact on how they behave. Scientists have finally managed to measure these shapes as electrons move through a solid U.
How do you even measure the shape of something as tiny as an electron? That seems impossible.
It's a very delicate procedure, and it wouldn't have been possible without incredible advances in technology. They use a technique called angle-resolved photoemission spectroscopy, or ARPES, which involves shining a very precise beam of light onto a material and analyzing the electrons that are ejected.
So what do they find? What do these electron shapes look like? Are they little spheres, cubes?
It's much more complex than that. Their shapes are more like intricate patterns and forms in higher dimensional spaces, and they can only really be described using the language of quantum mechanics. But the point is, by understanding these shapes, we can gain a deeper understanding of how electrons interact with each other and with their surroundings.
So it's not like we can just draw a picture of an electron and say that's what it looks like.
Right.
But we can study these shapes and learn how they influence the electron's behavior. Why does that matter so much?
The shape of an electron can affect how well it conducts electricity, how it responds to magnetic fields, and even how it interacts with other particles. So if we can figure out how to control the shape of electrons, we can potentially design materials with very specific electronic properties.
Wait, so we could essentially engineer materials to be better conductors, more resistant to heat, or even exhibit entirely new properties that we haven't even thought of yet.
You got it. The possibilities are vast, and we're just beginning to scratch the surface.
That's amazing. And speaking of exciting new materials, there's another area of research I want to touch on, something called Kagome metals.
Oh, yeah.
Okay, Kagome metals. This is a new one for me. What makes them so special?
Kagome metals get their name from a traditional Japanese basket weaving pattern. The atoms in these metals are arranged in a similar woven pattern, and this unique atomic structure gives them some very strange and fascinating electronic properties.
So the arrangement of atoms in these metals is like a woven basket. That's a pretty cool visual.
Yeah.
But what's so special about their electronic properties?
Well, scientists are particularly interested in how the vibrations of the atoms in these metals, which are called phonons, interact with the electrons.
Phonons, aren't those like sound waves traveling through the material?
Exactly. And in Kagome metals, these phonons can do some pretty unexpected things. They can interact with the electrons in a way that creates patterns of electric charge called charge density waves, or CDWs.
So we have these patterns of electrons forming in the material, kind of like standing waves. What effect do these CDWs have?
They can dramatically change the material's electronic properties, and scientists are still trying to understand exactly how these CDWs form and how they interact with other quantum phenomena in Kagome metals. It's a bit of a wild card in the quantum world, full of surprises and untapped potential.
Wow, we've covered so much ground already, and it feels like we're just getting started.
For sure.
This is why I love exploring these topics. It's a constant reminder that there's always more to learn, always more to discover.
I couldn't agree more. The universe is full of mysteries, and the quantum world is one of the most fascinating and perplexing realms we've encountered.
Before we move on, I want to take a moment to hear from you, our listeners. What's resonating with you the most in all of this? What are you most curious about? We're all on this journey of discovery together, and your perspectives are just as valuable as ours.
We'd love to hear your thoughts. Reach out to us on social media or leave a comment. We're always excited to connect with our amazing community.
All right, now that we've laid the groundwork, let's dive even deeper into the quantum realm. Next, we'll be exploring the potential implications of these discoveries, both for our technology and for our understanding of the universe as a whole.
It's going to be a wild ride, so buckle up. Welcome back to Complicated Stuff. It's truly amazing to think about how these quantum discoveries could reshape our world, wouldn't you say?
It really is mind-blowing. We've already talked about things like faster computers, more efficient energy transmission, and even a deeper understanding of gravity. But I'm curious to hear about some specific real-world applications that might emerge from all this research.
Well, one area that has everyone buzzing is quantum computing. We touched on it briefly earlier, but the possibilities are truly astounding. We're talking about computers that could be millions of times faster than anything we have today.
That's almost impossible to even grasp. What kind of problems could we solve with that kind of processing power?
Honestly, it's hard to even fathom the potential. Think about fields like drug discovery materials, science, artificial intelligence.
Right.
They would all be completely revolutionized. We could design new medicines with incredible precision, create materials with unheard of properties, and develop AI systems far more sophisticated than anything we can currently imagine.
I remember when I first heard about quantum computers, it felt like something out of science fiction.
Oh, for sure.
But the more I learn about them, the more I realize that they're not just about speed. They can tackle problems that are completely beyond the reach of classical computers, right?
Exactly. Quantum computers operate on the principles of quantum mechanics, like superposition and entanglement. This allows them to process information in a fundamentally different way than traditional computers. We're talking about solving problems that would take classical computers billions of years to crunch through.
So we're talking about cracking the codes of the universe potentially. But let's get practical for a moment. How close are we to actually having quantum computers that we can use in our everyday lives?
It's a field that's moving at an incredible pace, but there are still significant hurdles to overcome. Building quantum computers that are large enough and stable enough to be truly useful is a huge engineering challenge.
So no quantum laptops in our backpacks anytime soon.
Not quite yet, but we're getting there. Companies like Google, IBM, and Microsoft are investing heavily in quantum computing research, and there are already small-scale quantum computers being used by scientists and researchers. It's only a matter of time before we see larger, more powerful systems.
It's definitely an area to keep an eye on. So quantum computing is one exciting avenue. What about other potential applications of these quantum phenomena we've been discussing?
Well, another area that could see major disruption is energy. Remember those edge states we talked about where electrons flow without resistance?
Oh, yeah.
Imagine transmitting electricity with virtually no energy loss.
That would be a game changer, for sure. No more wasted energy, no more heat generation. our power grids would be incredibly efficient.
Precisely. And it's not just about efficiency. We could also use these quantum phenomena to develop entirely new ways to generate and store energy.
That sounds intriguing. Can you give me some examples? What are researchers working on?
One really promising area is the use of quantum dots. These are tiny semiconductor particles. To create super efficient solar cells, imagine harnessing the power of the sun with far greater efficiency than we can today.
Wow. So we could potentially meet a large portion of our energy needs using solar power? What about storing all that energy?
That's where things get even more interesting. Researchers are also exploring ways to use quantum phenomena to develop new types of batteries that can store far more energy than current technologies allow. We're talking about a potential revolution in battery technology with implications for everything from electric vehicles to portable electronics.
The possibilities are truly staggering. It seems like these quantum discoveries have the potential to touch every aspect of our lives. It's almost like we're stepping into a science fiction novel, but it's all based on real science.
It is a bit surreal, isn't it? And it's not just about technological advancements. These discoveries are forcing us to re-examine our fundamental understanding of the universe and our place in it. We're starting to realize that the universe is far stranger and more wonderful than we ever imagined.
It's humbling in a way. We're constantly reminded that there's so much we don't know, so much yet to be discovered.
Exactly, and that's what makes this whole field so exciting. The quantum world is a vast and uncharted territory, and we're just beginning to explore its wonders. Who knows what incredible breakthroughs lie ahead?
That's a perfect point to transition to our next topic. We've talked about all the incredible potential benefits of these quantum discoveries. But as with any new technology, there are always potential risks and ethical considerations to address. What are some of the concerns we should be thinking about? It's incredible to think that we're talking about technology that could potentially crack the codes of the universe, create new energy sources, and even reshape our understanding of reality itself. But with that kind of power comes a lot of responsibility. What are some of the potential downsides or ethical concerns that we need to consider as we venture further into this quantum realm?
Well, that's a great question, and it's one that scientists, ethicists, and policymakers are grappling with right now. One of the biggest concerns is the potential impact on data security. Quantum computers, with their immense processing power, could potentially break the encryption methods that currently protect our online data, from financial transactions to personal information.
Yeah, that is concerning. It feels like every time we come up with a new security measure, someone figures out a way to break it. Our researchers working on ways to counter this potential threat.
Absolutely. Cybersecurity experts are already developing new forms of encryption that are specifically designed to be resistant to quantum attacks. It's a bit of a cat and mouse game, but it's essential to stay ahead of the curve.
It definitely sounds like a crucial area of focus. What about other ethical considerations? What are some of the broader societal impacts we might see from these quantum technologies?
Well, another area that's generating a lot of discussion is the potential for these technologies to be used in ways that could harm individuals or society as a whole. For example, quantum computers could be used to develop autonomous weapon systems that can make life or death decisions without human intervention.
It's a reminder that every technological advancement comes with the potential for both good and bad. It's up to us as a society to ensure that these technologies are developed and used responsibly.
I couldn't agree more. We need to have these conversations now before these technologies become so advanced that we lose control over how they're used. It's about striking a balance between fostering innovation and safeguarding our values.
I think that's a great point to emphasize. It's easy to get caught up in the excitement of all these mind-blowing discoveries.
Yeah.
But we also need to proceed with caution and thoughtfulness.
Exactly. It's about approaching this new quantum era with a sense of wonder and responsibility. We have the potential to solve some of the world's most pressing problems, but we need to do it in a way that benefits all of humanity.
I like that it's about progress with purpose. But we've covered a lot of ground today, Jenna. We've gone from electrons dancing on the edge of materials to the potential for quantum computers to revolutionize our world. And we've even touched on some of the ethical considerations that come with these advancements. And it's been an incredible journey through the quantum realm.
It really has. I always enjoy these conversations about these complex topics. It's a reminder that the universe is full of surprises and that there's always more to learn.
Absolutely. And speaking of learning, before we wrap up, I want to turn it back to our listeners. What are your thoughts on all of this? What excites you the most about the potential of quantum technologies, and what concerns you? We'd love to hear your perspectives.
We're all in this together, figuring out how to navigate this exciting and uncharted territory. So please share your thoughts with us on social media or leave a comment. We're always eager to connect with our amazing community.
Thanks for joining us for this episode of Complicated Stuff, everyone. We hope you've enjoyed this look into the world of quantum phenomena.
And until next time, keep exploring, keep questioning, and never lose that sense of wonder.
See you all on our next adventure.